Well, welcome back to another episode of Down the Rabbit Hole with Building Inspector Steve Nason. Today we're going to talk about ICF construction and primarily focusing on the footing aspect. As we roll through these series, we'll go from the footings all the way up to the underside of the truss with these things. As these sometimes can be complicated, we want to take these in little chunks, and in case of this one here, it's a little 10-minute segment on how to deal with ICF footings. And as always, these are meant for a guide for building inspectors or for designers to know where to look for these things and hopefully learn a little bit. Anyway, so let's just take a dive down the rabbit hole. Okay. There's 4 paths for ICF construction. One of them would be the National Building Code of Canada. Now there's some restrictions with that and some issues with that, but again is that there's a compliance path in the National Building Code of Canada that gets us down that road for ICF. One of them would be openings within a corner. There's limitations on how close you can put an opening in within a corner. There's heights, and so there's a bunch of other things. And as well as the National Building Code tends to be more conservative with their design opposed to the other methods. Okay, the other one is Insulating Concrete Form Manufacturers Association Manual, the ICFMA. Now that's more like a one-stop shopping for ICF construction. It's a design manual that was put out by 6 different manufacturers in an effort to get one concise engineering document that we can understand. I would think that's the path forward, as everyone would know that we sometimes have various manufacturers, manuals, and they all have a little bit of differences. So this way, once you get to understand this manual, so far it'll cover at least 6 manufacturers, which is a good thing. Now the other one is a manufacturer's manual directly from the manufacturer itself. Now again, they may have chose that route, but one of the things you have to watch for is make sure the manual is current for the code you're dealing with. Like here in New Brunswick, we're at the 215 National Building Code, and again, we want to make sure that manufacturer manual references the 215 code. And the fourth way, which would be more site specific, okay, it would be an engineered system, okay. So that gives you 4 paths for compliance, so which gives you quite a few options. Now, there is a couple things we need to know, okay? In all these cases, we need to know the snow load of your area, the hourly wind pressure, the seismic area, equivalent spectral response acceleration numbers, and those are found in the National Building Code, okay, under the climatic data. The only one you won't find is the equivalent spectral response acceleration, which is in the ICFMMA Manual, and that particularly deals with that. But the other items are both found in the National Building Code and the ICFMA Manual. The other thing you'll need to know is where to find the bearing pressures for the various soil conditions that you're dealing with. Now those will find in the National Building Code, and as you see, like in the area where I live, we have a lot of glacial till, which is 200 kPi. What we'll do is we'll go into that a little bit farther on the episode. The other thing you need to know is your tie spacing, your block height, and your wall thicknesses. Those are, as I said, your essential building blocks for reading and understanding the manuals. Okay. Now again, as you'll see here, this is the ICFMA manual. You can see in there where they've shown us in St. John area, you got a snow load of 2.3 kPi and an hourly wind pressure of 0.5 kPi. Again, those are found in both the National Building Code and the ICFMA manual. And once again, you'll see the seismic data here in the charts. Okay, so those are a couple things that we need to know. And once again, is that we're looking at the bearing capacities of soils. Our limiting bearing pressure is, you'll see here that it's I think it's 75 kPi that we allow. There is a minimum of 75 kPi. Don't see it there, but it is 75 kPi. There we are, right there. Okay, minimum allowance is 75 kPi. So the National Building Code talks about the bearing pressures for footings and foundations and those things, and that's found in 915 of the National Building Code. And again, is that you have to remember that 9, you can only use these for of construction not more than 2 stories in height with a maximum floor to height of 3 meters, containing only a dwelling unit. Now that's the critical element. Again, is you can't use this for a duplex, you can't use it for a commercial, it's only used for a dwelling unit, okay? So that's the criteria that lays it out. And again, is that in the materials and systems 9.3, they talk about, again, 2 stories in building height and floor to height 3 meters, and buildings of light for of construction containing only a dwelling unit, okay? One of the things that I found a little odd that's in here is that it also talks about the lapping of the bars, okay? So you need to look at that lapping of the bars. Let's go back here. Yes, so again, 450 millimeters for 10 M bar, not 650 for 15 M bar. I found that a little strange that it's in that section, but it makes sense. So you have to remember that all the rebar in any of the ICF, there's a lapping allowance that's required. Okay, and then they talk about this. Where do we go? Oh, there we go. So the ICFMMA Manual, which I talked about, is the design for Part 9 structures, okay? And you can see the 6 manufacturers that have signed on to this manual. Again, as it talks about Part 9, and it gives you some stuff. These are pages out of the manual. And the various stamps, okay, are there, okay? The only time, now when you get into the various tables, you'll only see one stamp because there's not enough room for everybody's stamp, okay? So once again, like here in the province of New Brunswick, you'll see the stamp right here for the province of New Brunswick, and if you're in Ontario, there you go, you know, likewise. So it's a stamped document, which is helpful for building inspectors. And again, they talk, there's a table of contents, so they'll walk you through the various different items, so it's easy to follow. Okay, now again, we talk about it's design 1 floor below and minimum 2 stories above grade, pretty similar to the National Building Code, okay? And Part 9, and so that, and then it has some building areas and parameters in there which you should look at. Now they also talk about, as I said earlier, the lapping bars. Now this here, I'll go back here a second. You'll see this is the notes section of the book. I would say that's a must-reading part of it. So you need to look at it because they'll talk about, say, the lap bars here. And they talk about reinforcement steel, those things. So that's the must-reading section of this manual. They'll talk about shear walls. We'll get into that a little bit later. Reinforcement, provide 1 continuous bar maximum from the top of the wall at all floor levels. See, so those things, that's why I have them highlighted, because again, that section is a must-read section. Okay, in our case, we're going to be talking about strip footings for now and foundation walls. So strip footings is get us going. So you can see I've highlighted it here. So again, you can walk down through it, and they talk about the bearing pressures and those things in there. So that's just an indication of that. All right, so now we're into the National Building Code of Canada, which is the other prescriptive manual that we can use. As you can see, they talk about, we hear of live loads of 2.5 kPi, and they talk about the width of the strip footing, okay? All right, so it gets you, it's in, then you can see up here where it says above ground, flat insulating concrete form walls, which is the ICF, okay? So this deals with the ICF, and you can see if I'm supporting 1 floor here, the exterior wall width is 250 millimeters, okay? So that's get you going in there. That's 915.34, as you can see. All right, so here's another one that you kind of got to watch, okay? You've got to bump out your footing width, okay, for each story of flat insulating concrete wall supported by the foundation wall. It's not the foundation wall. It is what's supported on top of the foundation wall. So you got to be careful in that. All right. So again, and they talk about interior walls and exterior walls, interior here and exterior there. But you have to be mindful that, again, as if you're setting an ICF wall on top of an ICF foundation or a regular foundation, you need to bump out that strip footing a little bit wider. And we'll show you here in the next few minutes. And they also talk about that you can either put a shear key, right, in the bottom of that. And typically what happens with that is they'll take a 2x4, set it in the cement before it sets up, then pull it out, and that gives you a shear key. Or you can dowel it. You have either choice, okay? And the doweling here is not less than 15 M-bar, spaced 1.2 meters on center. So you have that keyway or that doweling, and that also works. Okay, so if you look at this chart here, that's out of the ICFMA manual, you'll see a strip footing here, and again, there's your snow load, right? You have to watch that snow load, and there is a little bit of difference here because this manual deals with allowing varying pressures, but they really don't line up with the National Building Code, unfortunately. But what I'm saying here is that the minimum of the code is 75 kPi. All right, so we're down about 72. And again, you sort of have to marry this up, okay? For me, I looked at my glacial till, which is 200 millimeters, and I pulled it up to 144, and I'm looking at this, and I can go a one-story ICF basin with wood main floors, okay? So then I know that that's my 16 inches wide with 6 inches thick, okay? So it's a little bit of a dance, but again, it gives you an indication. Now, if you had a soils engineer, if you had some soils that were a little suspect about, of course your soils engineer would be able to give you the allowing bearing pressure of that soil. But most cases, as building inspectors, we'll go and look and say that we're looking for, it may be on rock or stiff clay, but around here we generally use like a till. So again, that's a little bit of a dance you have to make there. But any of these numbers here are well above the code, so you just have to, get that. They'll get that straightened around, I imagine, at some point, right? And this one here is interior not supporting minimum exterior strip footings not supporting roof loads. Okay, so that would there's that second chart in that manual. Okay, so let's just talk a little bit about our doweling, okay? So when you look at your dowels, right, you need to find, remember we talked about the seismic zone, okay? So we need to know our seismic zone. We need to know the backfill height of the wall, which is from here up to here. In some cases, if you got an 8-foot backfill height, right, and you're using 10 M-bar, you got to go every 16 inches. All those would be every 16. If you're using 15 M-bar, you're 24. And so it all varies by your backfill. So again, it's that this backfill height was 4 feet, right? Okay. Oh, sorry about that. We'll go back and we'll find out that we have to use a 24-inch bar, and 10 M-bar, 24 inches. So again, that's all depending on the backfill height, and you'll find that in that ICFMA manual. Okay, so let's just have a quick look at these two examples, okay? One of them would be our National Building Code calls for that for a 10-inch by 4-inch footing, okay? And the ICFMA calls for 16 by 6. Not a problem. You don't have to bump that out because you're supporting a wood frame up there, and so this is just a standard strip footing, okay? Now, where it does get a little bit different is that you've got one wall here, right? That's your foundation wall. Then you have to bump this out by 150 or 6 inches. Bump this out by 6 inches because, again, you got one floor supported by the foundation, 2 floors supported by the foundation. So at the end of the day, you're going to end up with roughly right on a 20-inch by 10-inch footing, and the ICFMA is 26 by 10. So that gives you a couple ideas. So I hope that that these strip footings have been a little bit helpful. We'll next dive into the foundation walls. Take these a little bit of a chunk at a time because again, these ICF foundations, there's a lot to learn, there's a lot to understand, and as some inspectors see them daily, some inspectors don't. So, you know, again, we want to be able to have a good reference. So if there's any notes or comments, you can shoot me an email, or you can leave the comments down in the section below. Once again, thank you very much, and we'll see where we're going to go on the next rabbit hole dive. Take care.